Electrostatics deals with the properties of source charges at rest, but the attached charge may be in motion. Source charge means a charge that exerts a force on another charge, and that another charge is attached charge. An electric charge is a fundamental property of a body that causes it to feel a force of attraction or repulsion towards another body. There are two types of charges, positive and negative. Charge on proton is positive and charge on electron is negative. Now the question is, how do we know that there are two types of electric charge? A body is actually electrically neutral if it contains equal number of positive and negative charges. When two bodies are rubbed together, the electrons from one body transfer to another body, and hence their neutrality is distributed. A body which gives electron becomes positively charged, and the body which gains electrons are negatively charged. Please note that by convention, actually, we call them positive and negatively charged. It was Franklin who named them positive and negative charges. In this example, when glass is rubbed with silk, the glass becomes positively charged while the silk becomes negatively charged. The glass rod is attracted to the silk because their charges are opposite. Two similarly charged glass rods repel each other. Similarly, two similar charged silk cloths repel each other. So it means that charges of same nature repel each other and charges of opposite nature attract each other. These attractive and repulsive forces among the charges are called electrical forces. Can charges be separated? When we rub two bodies together, charges can be separated, yes. For example, here, both amber and cloth are originally neutral, as both have equal positive and negative charges. When we rub both together, some negative charges are transferred to the amber, and as a result, cloth leaves with a net positive charge. When we now separate them, the amber and cloth have net charges, but the absolute value of the net positive and negative charges will be equal. There are three basic properties of charge. Number one, additivity of charges. Number two, quantization of charges. And the third, conservation of charges. First, additivity of charges means a charge of a system can be added by simple algebra. It means charges are scalars and can be added by simple mathematics law. Suppose we have a system having charges q, 2q, minus 3q, and 5q, and we simply add them up to get the total charge on a system. The charge on a body could be q is equal to plus minus ne, where ne is a whole number and e is the elementary charge. For example, the elementary charge on electron or proton is 1.6 and 10 raised to power minus 19 coulomb. So the electron is actually transferred during the electrification process, but always in an integral number. It means that charge is transferred must be integral multiple of E. But in 1964, Gilman and Zweig independently proposed that all elementary particles, for example, electron and proton, are built up of elementary particles called quarks. So according to the quarks model, the composition of proton is up, up, and down, carrying charges 2 over 3e, plus 2 over 3e, and minus 1 over 3e, where plus 2 over 3e is charge on up quark and 1 over 3e is charge on down quark. Please note that till now, the existence of quark is not detected experimentally, but their existence is proved indirectly. In the future, if their existence are experimentally possible, then we just need to change the definition of quantization from E to E over 3. But Please remember the idea of quantization will still be same. The next property is conservation of charge. The electric charge can neither be created nor destroyed, but it can only be transferred from one body to another body. But please keep in your mind that the total charge of the isolated system remains constant in any process. That process could be physical, chemical, or nuclear. As we have already discussed, a case of two bodies where we take a glass rod and a silk, both were neutral initially, but when we rub them together, charge is transferred from glass rod to silk. But at the end, the total charge on both still remains constant. Here is a second example. When a gamma ray photon of energy equal or greater than 1.01 mega electron volt comes closer to the nucleus, the electric field of the nucleus would annihilate the gamma ray and will create a pair of electron and positron. But the total charge will equal to zero on both sides. And the second, when electron and positron come closer to each other, they form two gamma ray photons, each of energy 0.51 mega electron volt. But here again, the total charge on both sides is equal to zero. Here is an example of decay of uranium-238. The Z number of uranium-238 is 92. It means it has 92 protons. It means charge is 92e. The thorium has Z number 90. Hence, its charge is 90e. And here is alpha particle having charge 2e. So, on both sides, before decay, the charge is 92e. And after decay, the charge is still 92e. So, it means that the conservation of charge holds.